So now we're going to move on to using the calculator to solve a system of equations. And in so doing, we're going to move from just linear systems of equations to nonlinear systems of equations. Specifically, we're supposed to do linear quadratic and quadratic systems. Okay. That's mostly the same slide you've seen. So here's the steps to using a calculator to enter and solve a system of equations. Right? First, the equations have to be solved for y. Okay. If they're not solved for y, then you're going to have to take a step and solve them for y. Second, you're going to hit the y equals button, which is at the top left, right? And if there's only two equations, then on y1, you put the first equation. On y2, you put the second equation. And then in a perfect world, then you hit second, trace 5, enter, enter, enter. Right? So here's the y equals, right? And second, trace, and when you do that, you'll see a menu pop up and you hit 5. Man, those are new. Okay. So let's try it. And I'm actually using the slides that I used last class that are already filled in, because there's a lot of things like all the copying, pasting of the calculator screen, but you still need to follow through on all these steps. Okay, so we go to y equals clear. They're both already solved for y, so I can go directly to y equals clear and clear. So negative 3x plus 2, and enter, and 2x minus 3. Enter. Is everybody okay with just entering equations? You know how to do that. Okay, then you jump to the last step. Second, trace. 5 is said, you should see a menu there, and number 5 is intersect. So it's going to find the intersection point of the two graphs. So enter, enter, up. If you get to your screen like this, right, and it looks kind of goofy, which it does, then hit zoom 6. Right? Zoom 6 brings you to the regular standard view. In fact, you can see on mine right there that mine is thinking because it's got this little dot, dot, dot at the top right there. And sometimes it's hard to get it out of that other than turn it off. Second, on, and then turn it back on again. In fact, let me do this. So second, off, and then I turn it on, and I go back, and there's my equations, and now I should, let me do zoom 6. So everybody should see that view, right? If you don't see that view, do zoom 6 so that we're all starting at the same place at least. Right? The zoom key is right in the middle of the 5 buttons on the top. Okay, and now I'll do my second, trace 5, enter, enter, enter. And the intersection point, you see the cursor is on the intersection point right there. And it says 1, negative 1. Now, if I go through those steps more slowly, right, we'll see exactly what's going on with the calculator. Right? Second, trace 5. Okay? It's actually asking you the question, first curve, question mark, right? And notice in the top left of the screen, it says y1 equals negative 3x plus 2. Okay, and that is what we wanted to use, so we hit enter. That's good. Okay, now it says second curve, and notice that it says the other, y2 equals 2x minus 3. And that is what we want for the second equation. So we hit enter. And then it says, guess? Meaning, are you happy with the 2 that you just picked? Right? If you are, then you just hit enter. Right? At this point, we always just hit enter. And it jumps to that. There will be times in class, even today, where actually we've got like 3 or 4 of the lines have equations on them, and we have to like pick which ones we're trying to use. So, okay, let's see. Okay, let's try this one. Y equals 5x plus 2. 3x. This is the one we did by solve by graphing. I think it was the number 4 on the homework the night before. So I look at the graph. I should have 2 lines. I can see a solution. I can see an intersection point. So I go second, trace, 5, enter, enter, enter. And it looks like the solution is negative 1, 3, negative 3. Is everybody okay with those basic steps? Right? I mean, let us know, if you're not some part of this you're not getting, we need to get you unstuck because we're going to be doing this over and over again. What's that? You had 0, 1. Okay, so y equals 5x plus 2. You have 5x plus 1. Okay, now try it. Second trace 5. There we go. Now, enter, 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 enter. That's it. Okay. Okay, next. Not that. I need this next. Okay. Now I'm going to put these 2 on the screen. And notice what we see. Okay. You could do the same thing. Now, I can put this in, right? I can say negative 3x divided by 7. I can even say negative 3 divided by 7x, and it's not going to be wrong. But if you want to enter as a fraction, remember, the calculator will do this for you. It will make it look like a fraction, which will sometimes actually help you from making errors, right? This one is not that easy to make an error. But if I go negative, first I'll put in the negative sign, and then I go alpha y equals 1. And there's a fraction. So I can enter 3/7 in fraction format and not worry about whether I needed parentheses. 3, right arrow, 7, right arrow, x, and plus, again, you don't really need them, so I'm just going to say 13 divided by 7. Enter, right? And on the second one, I've got negative 1, I don't, is that clear? Negative x over 3. You can put it in as whichever way you want. Minus 7/3. Okay, now if we just go through the same steps, like right away, right? Go second, trace 5, let it draw the 2 lines, and then you hit enter, enter, enter. and it gives you an error. Because you can't do this unless the intersection point is actually on the screen. And if you go just hit the graph button to go back to the graph, you know, those two lines are intersecting. They don't have the same slope. So I know they're going to intersect, but it looks like they're going to intersect off the screen to the right. So you understand that if you hit the window button right here, that is giving the window the dimensions that it's got. You can adjust that, but what I would recommend is just go back to the graph and from there do zoom 3, right? Zoom 3 is zoom out. Zoom 3, enter. And that's when you start getting the axes that they look kind of different just because it's been zoomed out. Okay, now, does it look like you can see the intersection point of those two lines when you zoom out? It's hard to tell. If it is, it's like right at the right edge of the screen. Let me see if it'll work. Second, trace 5, enter, enter, enter. And again, it was too far off to the right. It's so hard to see because it's so zoomed out. But I need to go back one more time, right? Go to the graph and zoom 3, enter. And now you're really going back. All right, we're from outer space now. But does it look like we can see the intersection point is on the screen? You know, it looks like it's right around here. So now do second, trace 5, enter, enter, enter. And because the intersection point is on the screen, it goes right to it. 44, negative 17. Right? So you can't find the intersection point if it's not on the screen. So the easiest way, zoom 3, and you got to hit enter. It doesn't zoom out until you hit enter. Boom. So that was 44, negative 17. Okay. So that's your first U try. So who's got answers? Correct. Octo. Yes. Yes. Good one. Yes. Gillen? Okay. Did you do it? So where's your two equations? 2 plus x plus x squared. Negative 3x over 4. Did you forget the x? That's why you've got a horizontal line there. It needs to be negative. That was a 3x. So when it goes on the other side, it's negative 3x. Okay? It needs to be negative 3x over 4. Or 3, negative 3 fourths. Nope. Not quite. How did you do it? Okay, let me see the equations you put in. It's 38. You put in 39. Yes. So I mean, you got to be able to solve for y, right? These are the two equations that you should have gone in, and then at that point, you know, just follow the steps. It's foolproof. You get the right answer. Okay. Okay, so now we get into linear quadratic, right? So it means that one of the equations is going to be linear, but the other is not, right? In this case, it's a parabola, right? So, you know, there's 3 different possibilities here. The parabola could be intersected by a line in 2 places. It could like not intersect at all. That would be a no solution. Or it could intersect at just one point. So we don't know which one it'll be before we start. But so put these in the calculator, y1 and y2, and see if you can come up with this solution. So you see the first curve is the parabola. The second curve is the line. You say guess. Sure, go ahead and guess. And it looks like it's not quite rounding off, but it's there. Now, how do you know? I mean, just looking at it, how can you be sure that it's actually doing that? And that maybe it isn't just like barely peeling off one little piece. It actually is intersecting at two places. You just can't see at that zoom level. You don't see. Right? Here's something you can do to zoom in on one piece of the graph that might help you out sometimes. And it's actually the very first, go ahead and hit graph. If you've still got those two in there, hit the graph so it looks like that. And now do zoom 1, okay? Zoom 1 lets you drag a box over any particular part of the picture that you want. Like if I want to look at that intersection point and see what it is, right now it looks like my cursor is at 0.9, so it's a little bit up. Let me left arrow to get it a little closer to that. Okay, and when I'm ready to make one corner of the box, I hit enter. And then I move the cursor and watch it drag a box over, come on, this thing does that sometimes, over the intersection point. So now when I hit enter, I'll be able to see better. Is this thing actually crossing in one place or is it more than one? It looks like it's just in one place. So zoom 1 lets you drag a box and zoom in right where you want to be looking. Now, just so I'm not looking at this part of the graph, next I'm going to go zoom 6, which is zoom standard, to just bring it back to the normal thing. Okay. Okay, now try these two, x squared minus 36 and x minus 16. Right, if you just look at the graph, you can see the two sides of the parabola, and you can see that the line is here. Well, it's got a y-intercept of negative 16, so it's going to be down there, pretty low. So we can't see the intersection points. So clearly we're going to have to zoom out so that we see the intersection points. So we're going to do that. Zoom 3, enter. Okay, there's the parabola. There's the line. Crosses. How many solutions are there? Intersection points? It looks like there's 2, right? So let's go through the steps. Right? Second trace 5, enter, enter, enter. Second trace 5, enter, enter, enter. And you can see that it jumped to this solution right there. There's the cursor. The coordinates are -4, -20. The thing is, now we got to be able to follow those same steps and have it give us the other answer. And if we don't change anything, it's just going to keep going to the same answer. So what you have to do is, when you do the second trace 5 and it draws the picture, then use the arrow key to make the cursor go to the other, to go close to the other before you do the enter, 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 so that it'll go to that solution and not that one. So like this, right? You go second trace 5, right? And the cursor is blinking on that first intersection point. I'm going to hit the right arrow and move it so it doesn't have to be exact, because that's not the answer, right? Okay, if I'm okay with that position, then hit enter, enter, enter. And now it jumps to that solution, 5, -11. You doing this, Ian? Do you know how to do it already? Okay. So we should know how to put it in. You know, the perfect situation is you just hit second trace 5, enter, enter, enter. But you may have to zoom out if it's the intersection point's not on the screen. You might have to like move the cursor to get multiple solutions. Are we okay with that? Do you already know all this stuff? Some? Okay. So try that one. See if you can get however many answers there are. I don't remember. Either 0, 1, or 2. You know, if you have a normal zoom going, then you would see that picture right there. And you can see that intersection point. So the first one was 2, 4. Okay, but now, is it intersecting up high? I mean, does it have to? Is it possible they could actually like only intersect in one place? Yeah, it could if it was like straight vertical. It could go straight up the middle and then would never hit either of the sides of the parabola. But if it's not straight vertical, it's eventually going to hit one side or the other. So you need to zoom out and see that there's an intersection point that's just a little bit off the screen to find the other. But you should have got 2, 4. That was the one that was on the screen if you were at a normal zoom. Okay, now we go. Zoom 3. And to me, it doesn't look like it's actually quite there. I'm going to actually move my cursor closer. Where is it? No, we're way off. I cannot see. Oh, I forget it. Zoom 3. Enter. One more time. So I can hardly see what's on the screen, but I'm pretty sure it's intersecting twice now. So let me go second, trace, 5. And I'm going to go to, I can hardly see the cursor, but there you go. It's there. That's pretty close. Can you see it blinking there? So enter, enter, enter. Okay, now it's 1044 is the other one. 2, 4, 1044. Good with that? Okay. Okay, so now here's where it gets a little more complicated. In fact, the parabola is the only one of the conic sections, quadratic graphs of quadratic equations, that might have y to the first power. So you can just solve for y, like all the ones we've done so far. But a parabola could also not open up or down. It could actually open to the left or to the right. And if it does, that means it's got a y squared term, which means before you can put it in the calculator, you're going to have to solve for y. First solve for y squared, then take the square root of both sides, which means now you've got plus or minus. So when you enter it in the calculator, you're actually going to have to take 2 lines to enter that one. One of them will be the top half of the parabola. The other one will be the bottom half of the parabola. And then you still have to put in that line. So for our system, we're going to this is actually 3 different graphs right here. Okay, so let's enter those in the calculator. Okay, so the top half will be the positive square root. Second, square root 7x minus 3. Right. Down, clear. Minus, negative, second square root 7x minus 3. Enter. And now 2x minus 3. Okay, so notice that there's two intersection points, right? One of them is here. That's the intersection of the top half of the parabola and the straight line, right? The other is the bottom half of the parabola and the straight line. So we're going to have to, when we're going through our first curve, second curve, right? The first time we want to use this one and this one. The second time we want to use this one and this one. Okay, we always need this straight line, but we actually have to pick whether you want the top half of the parabola or the bottom. So let's see how that works. All right, so let me go to second, trace, 5, and it's going to, the first curve will automatically be on Y1, which is okay. We need it once. So I hit OK for first curve. Actually, I can't hit OK. Watch what happens when I say enter. Enter, enter. It won't move off of first curve. Why is that? Notice the coordinates at the bottom of the screen. There is no Y coordinate. So the cursor is not actually on a curve yet. Even though it says at the top left that it's going to use that, it's not actually on it yet. So I need to right arrow once or twice or 3 times until it's actually gotten on the curve. Okay, so now I'm going to take the first Y1, the top half of the parabola. Okay, it automatically goes to Y2. I don't want the Y2, right? I need the next one down. So I do a down arrow, and then it goes down to the Y3. See in the top left now it's got the straight line, Y3 equals 2x minus 3. That's the right second curve. Enter. So with those two curves, go ahead. And you see it goes to the intersection point of those two. Looks like it's 4, 5. Now we still got to find the one that's with the bottom half of the parabola. So there you're going to have to pick out that and the straight line. Second, trace, 5. Okay, I don't want that one for the first curve. So I down. Okay, that's good. The negative square root. And the line. And I guess. 0.75, negative 1.5. Okay, so this one, we've got to solve the first equation for y, which I've already done at the top. So now let's put that in their calculator. Right, put these 3 in the calculator. And actually, I can show you, this actually, it may not seem like it saves you much when you're just doing one problem, but when you do more than one of these where you're going to have a plus or minus square root, it can actually save you a lot, right? And that is, let me do the first one, the square root, clear. Second square root of 10 minus x squared. So here's another way to enter. If all you want to do is say the negative of what's on line 1, then put a negative. And then you see the vars key, V-A-R-S, which is just below the arrows. You hit vars, y var, arrow over to the y vars, and then 1 for function. And the first option is y1, so I hit 1. So now it's got negative y1, y2 equals negative y1. Okay, that's what we want. So if I put in the next example that we do, if I also have to have a plus or minus, I don't need to change that. That can just stay as the negative of whatever I put on the first line. Right? This one should be negative 3x plus 10. See what this looks like. Zoom 6. Okay, how many intersection points does it look like? $12? Come on, 1, right? It looks like it's 1. Obviously, there's a straight line. What is that other shape? It looks like an ellipse, right? But that's because of the way the screen is, the zoom that you're on. You're on zoom 6, that's zoom standard. If you go zoom 5, that's zoom square. That makes it the same in both dimensions. So zoom 5, it'll look like it's more like a circle. In the end, we really don't care. We just want to know the intersection point. There we go. I mean, it looks a little bit like a circle there. So does it look like the intersection point is with the line in the top half of the circle or the line in the bottom half of the circle? Looks like it's the top half, right? So when you go to picking out first curve, second curve, the first curve's got to be the top half, the positive square root, and the second curve will be the straight line. So y1 and y3. Here we go. Second, trace 5. y1 is good. We're on the curve. Don't want that one. So I arrow down to get the straight line. Enter, enter. So it looks like it's 3, 1. Let me snip that. Okay, try that one. See if you can get the 2 answers. Solve for y. Go through the steps. So are we good on this one? Anybody? Anybody? You don't say it's something. I'm going to move on. What? So, you know what you're doing. Do that again. Second trace 5. Okay. Okay, you're not on a graph.
Where am I?
I don't know, but you're not on a graph. So you need to, since the graphs are over there, you need to go left arrow. Okay, now it's on a graph because you got x and y coordinates. Okay. Now you got the negative square root. You don't want that. Try this again. Second trace 5. The first curve, that's the positive square root. Okay, and it's on there. So hit enter. Okay, now you don't want the negative square root. You want the line. So hit down arrow. Now it's the line. Enter. Enter. So it's positive 1. Okay. So, I mean, if you can't solve for y, you're going to be in trouble here, right? I mean, this one is y squared equals, when I add 1 and subtract 6x from both sides, get 1 minus 6x. So y is plus or minus the square root of 1 minus 6x. Okay. Now, according to the SOLs, we also do quadratic, which means you could have 2 parabolas, you could have 2 circles, you could have an ellipse and a circle, you could have any of these. So this particular problem, I mean, it's somewhat real world related if anybody's got Navy people in the family. I mean, this is the way Navy ships locate themselves at sea. Okay. A hyperbola is defined by the distance, the difference of distances from two fixed points, right? If the two fixed points are like radio transmitters, then when you take the distance, let's say a ship is at sea and you say, well, how long does it take to get the signal from this one, which I know where it's at, and from this one, and I know where it's at. By taking that difference, that defines a hyperbola, okay? And if you're lucky enough, you've got 3 stations, then you can make a comparison between 2 others. So that defines 2 hyperbolas. The ship has got to be at the intersection point of those 2 hyperbolas. So that's I'm sure these days on the ships that this is like behind the scenes being done by the computer and that. But I had a friend who was a retired Navy officer that said that they actually learned about this when they go through their professional military education for what he did. So he was well aware of this thing. Now hyperbola, these are both hyperbolas. You wouldn't know it by looking at them, but the way you know it's a hyperbola is because it has an x squared and a y squared term and they have opposite signs. Okay. If they were the same sign, like x squared plus y squared, that's a circle. Okay. But if they have opposite signs, that's a hyperbola. So if you wanted to read all the details of this problem and where these hyperbolas came from, it's page 660, example 4. They got pictures of the 3 stations and everything there. But these, if I solve these for y, I get these 2 equations. And how many lines is that going to take to enter into the calculator? It's going to take 4, because each hyperbola is going to take up 2, right? So I need to put in the positive and the negative, the positive and the negative, right? And then let's see what that looks like. Try to do that. Put it in the calculator. Okay, the first one, square root of x squared minus 16x. What happened to my calculator? Minus 16x plus 32. Okay, on the second line I've got negative y1, so that works. Okay, on the next one I'll put second square root x squared plus 8x minus 8. And then I'll put negative bars, y bars, 1, and 3 for y3. And now at a normal graph, a normal window, viewing window, okay, if we zoom out, because you can't hardly see the whole thing, zoom 3. So this is all the first hyperbola. Now this is all the second hyperbola. Hyperbolas, we've done hyperbolas before, right? Hyperbolas are the graph of an inverse variation, right? Remember the graph of an inverse variation? Looks like that. That's a hyperbola. It's got 2 branches. This one is kind of tilted at 45 degrees, but on this one, they're not. Right. Here's the first one. I believe it was this and this. Those are the 2 branches. And then here's the other one. Now, does it look like they intersect at all? It looks like they do probably intersect right in the middle, right there. Okay. So we don't actually need to be zoomed in to see that because that's right in the middle of the graph. So let me go back to the normal zoom. Zoom 6. Okay, so now I know I'm taking the intersection of the positive branches and the intersection of the negative branches because there's 2 intersection points. So I'm going to have to go second, trace 5. Okay, y1 is on the first positive branch. That's good. So I take that. Okay, but I don't want the negative of that. I need to go arrow down so that I'm on the other positive square root. And that one is actually not on the curve yet, right? See that it doesn't have a y coordinate? So let me right arrow until I get it. There we go. Okay, now I'm on the second positive branch. Enter, enter. And so that it's hard to see that it's blinking right on that intersection point. It's 1.66 repeating 2.8. Okay, define this other one, which is below the y-axis. I'm going to go second, trace 5, and now I need the other two. So the first curve has got to be negative y1. The second curve has got to be negative y3. And so it's exactly straight down below it. Okay. So that's using this to solve systems of equations. Could be as complicated as a quadratic and a quadratic. Most of the SOL questions, if they're actually a solving, it's usually like a linear and a quadratic. But there's one other thing that I wanted to show you, okay? And that is you can use systems of equations to solve equations like this that you might have had trouble with when we were solving quadratic equations. I mean, do you remember how we would have solved this? I mean, you would have had to get everything on one side, 0 on the other. I mean, it's factorable, but if you couldn't think of how to factor it, what else could you do? Quadratic formula, right? So you could have done that. On the other hand, you can do this. Take the left side of the equation and make it y1. Take the right side of the equal sign, make it y2. And then we look for their intersection point. Okay? So let's go ahead and do that. All right, we're almost done. Clear. So put the left-hand side, 24x squared plus 8x plus 2. Right, clear. And 5 minus 6x. And then I need to clear out these. And let me look at that at a normal zoom. Okay. So you could see it. This is a really skinny parabola. And then this is the straight line, which is the right-hand side. I mean, it's going to intersect in two places. Can we see them both on that? I mean, it looks like probably you can. I mean, clearly you see this one. But is that one on the screen or is it just off? I mean, you can try it. You know, if you need to, zoom out. But I think it's all right there. So let's do second, trace, 5, good, enter, enter, enter. So let's see, it found the first one, which was to the right. You could see because it's a positive x, 0.16, so it's right there. That's this one right there, 0.16 repeating, and the y-coordinate is 4. Okay, now if I want to find the one to the left of the y-axis, then I need to move the cursor when I go through this. Second trace, 5. And then let me go left arrow to get it closer to that. Okay, that's good. Enter, enter, enter. And that's the second point right here. Now the thing is, if we're solving this, we're doing this because we're solving an equation. That equation did not have y in it. We introduced y to make it into a system. So we don't care about these y values here. These are the solutions to the quadratic equation, the x values where they intersect. Right? So, I mean, that works for any kind of equation. It could be a logarithm equation, you know, exponential equation, whatever, you know, just Put one half side of the equal sign on y1, the other half on y2. Look for the intersection point. Always works. Okay, try this one. Just put it in. See if you can reproduce the graph. Okay, not an option. Do it. What do you notice about these two? They never touch. What does that tell you about this equation? There's no solution. Because the graphs don't touch, there's no solution, which is always possible. Okay, that's it. So I said next class we're going to have a test over, or a quiz over the linear system solving by graphing, substitution, elimination. These homework problems, these here, they come from the linear problems, and they don't say to solve with the calculator. They probably say solve with substitution. But I want you to do them with the calculator, just what we did today, right? You don't have to do any algebra. Just put them in the calculator and see what answers you get, right? These come from the quadratic systems. I think they do say solve with a calculator, right? And these are like going back to the section, which is solving quadratic equations. Again, it probably wants you to do it with quadratic formulas, something like that, but try to use the calculator, see if you can come up with a solution. And that is it.